Is light a wave or a particle? This is one of the most important and consequential questions in all of chemistry and physics. Light adheres to the model of wave-particle duality, meaning that in different contexts or frames of study, light acts as one or the other form, or both. The wave model of light concerns its manner of travel and light-to-light interactions, whereas the particle model involves energy transfer and the dynamics of interacting with other matter. We also have an equation for each model which sums up the dynamics of that particular form of light. It's worth noting that while these aren't the only equations for light, all other equations heavily relate to it. Likewise, the particle model of light is also called a photon, and it's described by quantifying how much energy it has. You may have noticed that frequency shows up in both equations, and this has major implications for describing light when it exhibits both models. We can simply use frequency in each equation, set them equal to each other, because frequency doesn't change based on which model of light we adhere to. Now we have all of these variables related to each other in a new equation, and we can rearrange and solve for any of them. Energy is the most common of these terms that we solve for, and because both of these two terms are constants, if we know one of these two terms, we can figure out the other. If we know wavelength, we can figure out energy and vice versa. And remember, we only combine the wave and particle equations together if/when the situation calls for it. So did you learn the following? There is both a wave model and a particle model of light. Both models are valid, but in certain contexts, it could be behaving as a particle, in another as a wave, or even both. C is equal to lambda times frequency, and E is equal to h times frequency are the main equations for each respective model, and in theory could be combined. But again, context is key, and we only do that if light is acting as both a wave and as a particle.